There are actually a few different ways to do this problem. Probably the simplest way would be to choose a u value of sine of 36t squared. Now that might not be your obvious first choice, so I think we should probably do this problem a few different ways. But let's see what happens if you choose this as your substitution variable. Taking a derivative of sine of 36t squared gives you the cosine of 36t squared, but you can't forget the chain rule, which says we have to multiply by the derivative of what was inside this cosine function, which is 72t. Now you'll notice right away that this piece of the du is right here, and we also have a t which appears right here in the integral. So it might make sense to look at the problem this way. Let's take the 5 out. In the original problem here, the integration variable should be a t, and let's divide both sides of this du formula by 72, and I'll move this t in front of the cosine. Okay, so if we do all of that, we get that this right here is our u, and we get that this combined with all of this is du over 72. Let's make those substitutions. We can pull the 72 in the denominator out, and we just get the integral of u du. Integrating u gives us 1/2 u squared. Multiplying our fractions gives us 5 over 144, and then substituting in what u is gives us the sine of 36t squared, that whole thing squared, which we typically don't write like that. We typically write this answer as 5 over 144 sine squared of 36t squared. Now you might be saying that's not what I chose for my u. Maybe you followed the rules from my previous video and decided that it made sense to use a u equals 36t squared. And I think that does make sense. That would give you a du is 72t dt. And again, I'll pull the 5 out of the integral, and I'll divide both sides of this formula here by 72. And then we can notice that this t dt right here is just du over 72. And then we can also notice that this 36t squared here and here is just our u. Well, what does that give us? Well, it gives us the sine of u times the cosine of u times du over 72. We can pull that 72 out, and suddenly we have an integral of sine of u times cosine of u du. And there are a couple ways to solve this integral, but one way would be with a substitution. Since I've already chosen u as one substitution variable, I'm going to choose w as my second substitution variable. I'm going to say that w is the sine of u, and dw equals cosine of u du. Again, I just differentiated the sine of u to get this dw here. Now you'll notice that this integral becomes just w, that's sine of u, dw. And I'm running out of room here, so I'm going to integrate this thing. You get 5 over 72. The integral of w is 1/2 w squared plus c, which gives us 5 over 144. W was the sine of u, so when we square that, we get sine squared u plus c. Now one last step, we substituted in our w variable to get this function in terms of u. We want our original variable back. We want to substitute our u equals 36t squared here to get our final answer in terms of t. That is going to give us the same answer that we got doing the substitution the other way. Now I should say that there's still another substitution that you could have used to make this problem work. You could have chosen u equals cosine of 36t squared. What would have changed here is that you would end up with a negative sign here, and you would end up with a cosine here. Let's take a look at that result really fast. Now if that was the substitution you used, you might look at this answer and say that it's incorrect because it's different from the answers that we got up above. But as it turns out, if we remember our trig identities, you'll remember that cosine squared is 1 minus sine squared. If we substitute that in for cosine squared and distribute this negative 5 over 144 through the parentheses, we get this here as our answer. And you'll notice that some random constant that we don't know plus some other constant that we do know add up to some other constant that we don't know. So we can just go ahead and call this 5 over 144 sine squared of 36t squared plus some constant we don't know. And that answer there looks shockingly familiar. Okay, I think we beat this problem into the ground. Let's call it good for this video.